Welcome to Spaceverse, your portal to cosmic adventures. The James Webb Space Telescope continues to probe some of the deepest regions of our universe. Each time it sends back data and images, our understanding of the cosmos grows sharper, richer, and far more mysterious. One of its most recent targets is Messier 106, also known as NGC 4258, a nearby spiral galaxy located in the constellation Canes Venatici. Scientists with the European Space Agency have released dazzling new images of this galaxy, captured using Webb's unparalleled infrared capabilities. And once again, the telescope has delivered something extraordinary. On the surface, Messier 106 may look like just another spiral galaxy, somewhat similar to our own Milky Way. But thanks to Webb's cutting-edge technology, astronomers have been able to peel back the layers of dust and gas that once obscured its heart, revealing astonishing details about its structure, composition, and most importantly, its supermassive black hole. So, let's explore this breathtaking new view of Messier 106 and why it's such a big deal for astronomers. First, let's talk about how Webb manages to see what other telescopes can't. At the core of its power lies a sophisticated near-infrared camera, a marvel of engineering that allows Webb to peer farther and deeper into the cosmos than any telescope before it. When we look deeper into space, we aren't just looking farther in distance, we are looking back in time. That's because light takes time to travel. The farther away an object is, the older the light we see. But there's another layer of complexity here. The universe is expanding. As light from distant galaxies travels across space, it gets stretched out, shifting toward the redder, infrared end of the electromagnetic spectrum. Astronomers call this phenomenon redshift. That's where Webb shines. Traditional telescopes, which observe mostly invisible light, are blocked by this redshift and by thick cosmic dust. Galaxies, after all, are messy places. Dust and gas absorb visible light, giving galaxies a seemingly impenetrable appearance. But infrared light passes through these dusty veils. With Webb's infrared eyes, we can see structures and details that were hidden before, peeling back layers of mystery from galaxies like Messier 106. And what a galaxy Messier 106 is. At the very center of the new image lies its heart, a supermassive black hole. Now, supermassive black holes are a fairly common feature at the cores of large galaxies, including our own Milky Way. But Messier 106's black hole is especially intriguing because it isn't quiet. Unlike the one in the Milky Way, Sagittarius A, which occasionally snacks on stray wisps of gas, the black hole in Messier 106 is far more ravenous. It is actively feeding, pulling in huge amounts of gas and dust from its surroundings. As this material spirals inward, it heats up tremendously and emits powerful radiation, creating a bright, luminous nucleus at the galaxy's core. This intense feeding frenzy is what makes Messier 106 so exciting to study. The Webb image clearly shows this bright nucleus, a glowing beacon that illustrates the raw power of a black hole at work. But the galaxy's beauty doesn't stop there. Webb's imagery reveals the sweeping arms of Messier 106, glowing streaks of gas and dust that arc out from the center. These arms are teeming with stellar nurseries and cosmic dust, creating a tapestry of color and structure. The different hues in the image aren't just for show. They tell us about the temperature and composition of the dust and gas. The cooler dust glows in shades of red, the warmer dust shines orange, while scattered blue regions reveal stellar dust scattered across the galaxy. Near the core, we see intricate teal, green, and yellow tones, each representing different distributions of gas, giving astronomers a map of how matter flows within this spiral system. It's a cosmic kaleidoscope, but one that holds deep scientific meaning. Every shade of color corresponds to physical processes, from star formation to gas heating, helping scientists decode the galaxy's life story. Now, here's where Messier 106 becomes even more fascinating. In addition to the arms we can see, this galaxy has two more invisible arms. These don't show up in visible light or even in Webb's infrared view. Instead, they appear only in radio and X-ray wavelengths. And unlike the star-filled spiral arms, these mysterious arms are composed not of stars but of hot gas. Astronomers believe these invisible arms are directly tied to the activity of the black hole. As gas swirls into the supermassive black hole, not all of it gets swallowed. Some of it is ejected outward in powerful flows, crashing into the surrounding interstellar medium. This violent process creates shockwaves that ripple out into the galaxy, carving out massive structures of hot gas. The European Space Agency compared this to waves crashing against rocks near the shoreline, sending spray shooting upward. In much the same way, the black hole's violent feeding sends outflows of matter that sculpt these hidden arms. This makes Messier 106 a cosmic laboratory. By studying these unusual features, scientists can investigate how black holes shape their galaxies, not just by pulling matter inward, but by violently pushing matter outward. It's a two-way relationship, one that has enormous implications for galactic evolution. So why do these observations matter? Every new glimpse of galaxies like Messier 106 helps astronomers piece together the puzzle of how galaxies form, grow, and change over billions of years. Black holes, once thought to be simple cosmic vacuum cleaners, are now understood as engines of galactic transformation. Their ability to both consume and expel matter influences star formation, the growth of galaxies, and even the large-scale structure of the universe. By capturing Messier 106 in such breathtaking detail, the James Webb Space Telescope provides astronomers with data they couldn't have dreamed of just a few years ago. From the swirling dust near its core to the hidden arms invisible to human eyes, every feature tells a story of energy, matter, and the violent yet beautiful processes that sculpt the cosmos. And beyond the science, there's something almost poetic about this. Here we are, a species on a small rocky planet orbiting an average star in the Milky Way, and yet we've built a machine that can look across tens of millions of light years to uncover the secrets of a galaxy like Messier 106. What once looked like a faint smudge in the sky through early telescopes is now revealed in vivid color and staggering detail, thanks to Webb's unmatched vision. It's moments like these that remind us how far we've come in our cosmic journey. From Galileo's first telescope to the Hubble Space Telescope, and now to Webb, each generation of instruments has peeled back new layers of mystery, and with each discovery, we are reminded of how much is still out there, waiting to be uncovered. Messier 106 is not just another galaxy. It's a glimpse into the intricate dance between black holes and the galaxies they inhabit. It's a snapshot of matter in motion, of energy released and recycled, of stars being born and dust being sculpted by forces we are only beginning to understand. The James Webb Space Telescope has shown us that galaxies are not static islands in space. They are dynamic, living systems shaped by the invisible hands of gravity, radiation, and cosmic dust. And in Messier 106, we see all of these forces at play in a way that is both visually stunning and scientifically groundbreaking. Looking ahead, observations like this will help astronomers refine models of galaxy evolution, star formation, and black hole physics. They will guide future studies, from understanding the earliest galaxies in the young universe to predicting the fate of galaxies billions of years from now. And who knows, perhaps by studying Messier 106, we may even catch glimpses of processes that mirror what once happened in our own Milky Way, helping us better understand the story of home. For now though, we can marvel at the image itself. A spiral galaxy, 23 million light-years away, brought to life in shimmering colors by the most powerful telescope humanity has ever built. A galaxy where stars are born, dust flows in rivers of light, and a black hole hungers at the core, reshaping everything around it. The James Webb Space Telescope has once again shown us that the universe is both more violent and more beautiful than we ever imagined. Messier 106 is proof of that, a cosmic masterpiece painted in infrared light, unveiling secrets that were hidden for eons, now revealed for all of us to see. And that brings us to the end of our journey into Messier 106. From its radiant spiral arms to its hungry black hole, this galaxy reminds us just how alive the universe really is. With every new image from the James Webb Space Telescope, we are not only learning about distant galaxies, we are learning about our own cosmic story. If you enjoyed this deep dive into Webb's discoveries, don't forget to like the video, share it with fellow stargazers, and subscribe to Spaceverse for more explorations of the cosmos. The universe is vast, mysterious, and ever-changing, and together, we'll keep uncovering its secrets one story at a time. Until next time, keep looking up, because the next wonder might already be on its way across the stars.